Today we are talking about angles of polygons. First of all, let's talk about what a polygon is, just in case you've forgotten. So these are all polygons. We have a triangle, a rectangle, a pentagon, and a hexagon. These are polygons because they are closed figures and they are made up of straight sides that are line segments. Okay, so we're really interested today in measuring the angles of these polygons. First of all, we're going to talk about the interior angles here. Okay, so we've already said that if you add up all of the interior angles of a triangle, that they add up to 180 degrees. And we've said that that's true no matter whether you're dealing with an obtuse triangle or a scalene triangle or an isosceles or any kind of triangle. You can add up all their interior angles and they will add up to 180 degrees. So today we're looking at dividing all of these other shapes up so that they actually are in triangles. And so we're going to draw diagonals. So we're going to pick one vertex on the polygon and we are going to connect it to every other vertex that is not adjacent to it, meaning every vertex that is not right next to it. So you'll notice when I do that to the quadrilateral rectangle that it divides it into two triangles. We can do the same thing by picking one vertex on the pentagon, and we can draw a line to each non-adjacent vertex, meaning that we're not going to draw one to this vertex, right? Because that would just be along the side of the pentagon, so it wouldn't really help us out. And we're not going to draw one to this vertex because, again, that would just be along the side of the pentagon, and so it wouldn't really help us out here. So you'll notice that then we have three triangles in a pentagon. Same thing can be done with a hexagon. Okay, when we do that, we end up with four triangles. Oops. Can't count today. 2, 3, 4. Okay. So what this is going to tell us is that since we know the interior angles of a triangle add up to 180, we can actually figure out how many triangles are in each polygon and multiply that number times 180. And that'll tell us what the interior angles, of that polygon are. Now, it's easier than it sounds. For example, we don't want to have to sit here and draw the lines for each vertex from the vertex to each non-adjacent vertex every time. So they've come up with a nice little formula. So you need to be sure that this formula is in your notes. And the formula is for the sum, meaning we're going to be adding up, of the interior angles of a polygon. Okay? It only works for the interior angles of a polygon. It won't work for something that's not a polygon, and it won't work for anything other than the interior angles. It's also really important that you know that N stands for the number of sides. Okay? So that's really helpful. Now, sometimes we are not interested in the interior angles. Sometimes we're interested in the exterior angles. So what do we mean by exterior angles? Well, if we look at this triangle here, if I take each side of the triangle and I extend it, okay, and you notice it kind of looks like a pinwheel when you do that, it's going to create three exterior angles. Okay, 1, 2, and 3. And we want to know what would those angles add up to. Same thing with a square or a rectangle or a quadrilateral. We're going to have 4 exterior angles here. And this is really more of a rule for this one rather than a formula, because if you are adding up the exterior angles of a convex polygon, we'll talk about convex polygons again in a minute, it's going to be 360 degrees. So the sum, meaning we're adding them up, of the exterior angles of a convex polygon are going to add up to 360 degrees. Okay? And that's just a fact. You don't have to do any calculating. You don't have to do any work. You just have to memorize that those outside angles, no matter how many there are, you could have 100 different sides, and the exterior angles are still all going to add up to 360 degrees. Okay? So we will look at some examples in class tomorrow. I really appreciate you watching. Thank you, and I hope you have a lovely afternoon.